Welcome, physics class.
Avery.
Daniel.
And Pauline.
Mr. Strike.
We'll teach you about circuits. The main variables involved in circuits are voltage, current, and resistance. Current flows from the positive to negative terminals of the battery. In a parallel circuit, the currents add up. In series, the current stays the same.
In series, each resistor is added up to give you the total resistance. In parallel, the inverse of each resistor is added up to give you the inverse of the total resistance.
If you have two of the variables, you can find the last one using V equals IR.
Obviously.
The 2 and the 5 ohm resistor are in parallel. So to get the total resistance, you do 1 over 2 plus 1 over 5 equals 7 over 10. That inverse is 1.43 ohms. To add that with the 15 ohm resistor, you're in series. So you do 1.43 plus 15, giving you 16.43 ohms.
The 3 ohm and 1 ohm resistor are also in parallel. So you do 1 over 3 plus 1 over 1 to get you 4 over 3, and then the inverse of that in order to get 0.75 ohms. The 0.75 is in series with the 10 and 4 ohm resistors, so that you just add those all together to get 14.75 ohms. The total resistances that we calculated for this area and this area are in parallel. So we then do 1 over 16.43 plus 1 over 14.75 to get the total resistance, which is 1 over 7.77. So the total resistance is 7.77 ohms.
Now that we found the total resistance, total current can be found using the equation V equals IR. To find the power, simply plug into the power equation P equals IV, or I squared R, or V squared over R. To find the resistance of a current-carrying wire, use the formula R equals the resistivity of the wire times the length divided by the cross-sectional area. A capacitor is a device used to store charge. The capacitance of the capacitor tells how well that capacitor can store charge. In series, the capacitance can be found by using the inverse of the capacitance of the first capacitor plus the inverse of all the others, set equal to the inverse of the total. In parallel, you can simply add up the capacitances of every capacitor. Use the formula Q equals CV for any capacitor. To find the capacitance of a parallel plate capacitor only, you can use the formula C equals EA over D. Capacitors also store energy. To find the potential energy in a capacitor, you can use PE equals 1/2 QV, that's the charge times the voltage, or 1/2 CV squared, that's the capacitance times the voltage squared. Kirchhoff's loop and junction rule can be used to carry out calculations within the circuit. In this example, you choose directions for each of the currents. In this loop, you can make the current I1. On this wire, it's I2. You then use them to make an equation for the current. By going from the negative to positive terminal of the battery, you add the voltage. When you go over a resistor in the direction of the current, you subtract the resistor times the variable for the current. This is derived from the equation V equals IR. These are then all added into one equation.
Thanks for watching.
Don't fail your test. What?